Okay, and now we have it here. And lab setup. Well, we have to wait for more students to come by so you can set up the lab. Okay, the way I'm gonna do is the following. Notes are here, and that's what we did yesterday. Okay, yeah. More students are coming. And we stopped. The same apply. This is here. Let's put here writing the same apply to time and mass. Okay, and I don't want the markups to show up. No markup, good. Okay. 25. Okay, so that's where it has stopped, right? We stopped around here last time. Page break. And today is, and I'm going to do the following. I'm going to start from scratch. I'm going to make this one notes, P06 notes, 1, 2, right? And I will keep the other open as well. Side and start another date here, 3023, and I erase everything. Let's hope it doesn't get stuck here. More students coming and go. Oops, didn't do anything. Doesn't look like it did anything. Ah, yeah. Let's try it again. Yeah, it does that little by little, unfortunately. Yeah, let's see. Yep. So the notes that you have there in Google Drive is exactly this notes that I generated back a year ago. Okay, and I'll be changing this notes slightly, and I will upload it as well. And if you prefer, to use that, it's okay. Either one is going to be okay. Okay. But I would say the one that I'm gonna follow strictly is gonna be this one that I haven't uploaded yet. Let's see here.
Is it on Canvas?
Yes, it's in Canvas there. I'm gonna show you where it is. Let's see if it's going to erase it or not. Oh, yeah. Okay, let me go there to Canvas. While this. Again, Canvas. Course. And that's fall 2023, right? Okay, so that's the main page. The student view is gonna look like that. Okay, on home, in home, make sure you have access to that. Here you go, here are the syllabus, here's the flyer, and those are the lecture notes. And I separated the lab notes from the lecture notes as well. Everybody can see that, right?
Yes. But
Let me
which one is which? Like the first one is the recent one?
this one, okay, right now, P notes, P06 lecture notes 1 is from last year's course,
Oh, okay.
okay? And
Oh,
I'm going
okay.
to have to upload this year's notes for you. It's gonna be almost the same, but there'll be some other things that are a little bit different. Okay, so for now, you have this one here, and then I will upload the other one. Let's see, and let's see how my deleting is going on here. Let's see. Okay, this is deleted. I'll save. I've been unable to save it. Your recent changes. Huh. Interesting, right? I hate that when that happens. He didn't delete everything. Maybe it was too much for him to delete. I'm gonna do better than that. Yeah. Instead of deleting all that stuff, I'm gonna copy that into a new document. Every now and then, I do not know why Microsoft Word is doing that to me. Now would be easier to do that. Bay Harbor, Fall. Okay, so I put 3 for now. Okay, save it. Good. And now I can resave it. And going back to my place where that document was located. Okay, now I delete this one. Okay, and rename it this one number 2. Good. Now I did what I want to do. Okay, good. So okay, go. What we are going to do today is what you're going to do today is set up a group lab. Okay. But I'm gonna wait a little bit, but I have to wait a little bit long, but I have to wait a little bit longer until more students come by. More students come by, okay? That's so what else can we do while we wait for the other students? Well, we can start talking about units and dimensional analysis. We can start doing that. Okay. And let me take I want to know you're a little bit of your background, okay, in terms of physics, whether you took physics before, okay, that's not going to be held against you whatsoever. I just want to have a feeling of if you're taking physics for the first time or not. First time physics, right? First time physics. Let's do that now. And so Camille, are you there? I don't see Camille here yet. Tessa, are you there?
Yeah, I'm here.
Okay, are you taking physics for the first time, Tessa, or you already took before?
Yeah, this is my first time.
Okay, you didn't even take in high school, right? Okay.
No.
Okay. Now let me see here what I'm gonna do. What am I doing here? There's something wrong here. This one is supposed to be 28. What's going on here? Ay, 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 ay. Yeah, this one is supposed to be 28. Ha! I see. I did something that was not right. And oops. My computer is not working. Okay, now you did it. Good. Now let's try it. This one is going to be 28. Okay, and now we've got it right. Okay, that's going to be 0 and 1 here. That's going to be 0 and 0. And Chewy, are you there? I don't see Chewy there. The next is going to be Destiny. Did you take Destiny? Did you take physics before?
Yeah, I took it in high school.
High school. Okay, good. So you're already familiar with some of the concepts that we're going to cover. That's good. That's good. That's Destiny. Thank you very much. And Gael Garcia.
I'm here.
Okay, did you take physics before, Gael?
Yeah, I took it in high school once.
Okay, that's good. And Eleodoro Gastelum. Eleodoro, I don't see Eleodoro there, right? Yep. Next, Elisa Gonzalez. I don't see Elisa either. Ridwan Harrison.
Howdy, and no, I haven't.
You said have not?
Nope.
Okay, thank you. And Ashley. Ashley doesn't look like he's here. Next is James Kim. I don't see James either. Emily Kotko. I don't see Emily either. And Norberto Lopez.
Oh yeah, I'm here, and I've never took physics before. It's the first time.
Okay, thank you, Norberto. Thank you for sharing that with me. Annabelle Madrigal. Annabelle, are you there? Took physics before. Let's see, took physics. Let's put it this way. Took physics before. Right? Yes and no. And let me see, Annabelle is not answering, so I want to put a star in her name here. And next one is Vanessa Monique Mena.
Hi, good morning. Yeah, I took physics in high school.
That's Vanessa?
Yeah.
Okay, you did take physics in high school. Okay, good. Next one is Nazmoon Miller. I don't see Nazmoon there. Catherine Pacheco. I don't see Catherine either. Camden Park. Hello, Camden. I cannot hear you. You might want to type in the chat in the chat window. Let's see, Camden, but can you hear me? Okay. Let's see, we're talking to Camden, right? Okay, Camden has. Let me see. Looks like Ridwan, right? Did Annabelle talk to me? Okay. Good one. Okay, didn't say. Okay, good. And next one is Victoria Preciado.
I'm here, and yes, I did take it in high school.
Okay, thank you. Ay, 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 ay. My computer is okay, good. Okay, good. Now it's working. Now, Alexis Richardson.
I'm here. I took it in high school.
Okay, Alexis, right? Okay. And Marcos Sanchez. Who was that who just came in? Was that Alexis or Annabelle?
Professor, can you hear me?
Yeah, who is that? Catherine?
Yes, I've actually been here. It's just that my microphone wasn't working for some reason. And I took physics in high school.
Okay, you did. Catherine, right? Okay,
Yes.
1 and 1. And let me see, what about Alexis?
Yeah, I'm here, and I took
Ah,
it.
okay, good. Thank you. So you did take it. Okay. And last one, Marcos Sanchez. Marcos Sanchez there. Okay, good. So let's see here. Doesn't look like Marcos. I'm here. Just you just added. Okay, nice to know. Let me put it your name here as well. Anybody else who added and it's not in my roster right now? Anybody else? And okay, and your last name is Martinez, right, Eric?
Yes.
Okay, let's see, you were not on Monday, right? But you're here today. Did you take physics before?
No.
No? Okay, and we have how many? 12, okay, good. So we're in good shape here. And Annabelle, are you there, Annabelle? Okay, Annabelle must be away from her computer. Good. Thank you very much for sharing that with me. And now what we have to do. Let's talk about units. Since upload failed. So I wasn't upload this file. Save a copy. Let's see. Good. Let's see if it works now. So let's talk about units, right? Let's go back to what we have here. Every quantity and definition in physics has units. Okay, so here you go. Every quantity and definitions in physics have units. Units exist to distinguish one measurement from another, one measurement from another one. Okay, from another one. The units are there. Yes, I will upload. In this meantime, you can, let's see, Gael is asking whether we'll upload notes later on. Yes, I will upload it. In this meantime, you can follow from the old notes, okay? So it helps you out follow the lecture. Okay. So units exist to distinguish one measurement from another. It's just like units are just like apples and potatoes, right? Apples and oranges, apples and potato. You cannot sum oranges with apples. Okay, you cannot sum oranges with potatoes, but you can sum oranges with oranges, right? One orange plus one orange is equal to two oranges. It's the same thing with units. Okay. Some let's write like that. Some there's a name, some operations, right? Some operations cannot be done with units. Okay, even better. Let's put it this way. You can operate. You can make operations. Between units, but some of them are not allowed between different units. Okay, so let's say this is just like this behave just like fruits, right? Different fruits behave just like different fruits, right? You cannot sum an orange with an apple, okay? Or an orange with a pineapple. However, you can sum and subtract, right? You cannot sum and subtract an orange with an apple or an orange with a pineapple. However, you can sum and subtract an orange with an orange, with another orange, and so on. The same thing applies to units. The same thing applies to units. You can, for instance, here you go. For instance, you can sum and subtract 3 meters with from, right? With from 2 meters. It's possible to do that. When you do that, you know, if you're summing 3 meters plus 2 meters, you get 5 meters. Similarly, if subtract 2 meters from 3 meters, you are going to get 1 meter. So units work just like operation with units is just like a regular algebra. Okay. However, you cannot sum 3 meters with 1 second. You cannot sum and subtract, right? And subtract 3 meters with 1 second. Or sum and subtract, or sum and subtract 3 meters with, what's the other unit? With 1 kilogram. You cannot do that. This is not allowed. This is not allowed. Okay. However, you can, you know, multiply and divide units among themselves. Different units, and divide different units. This is possible. Different units among themselves. Okay, can you give me an example of a multiplication and division of different units? Something that you use in the day-to-day life. Anybody can just go ahead and type there in the chat box, right? Give me an example. Think about an example. Think about an example. Think about an example in which you have compounded, right? Compounded units. Think about an example in which you have compounded units in your day-to-day life. In your day-to-day life. Okay, think about it. I'll give you a little bit of time there to think about that. You should have one that's very easy to recall. because it applies to our day-to-day life. Mouse per, yeah, here you go. Martinez, right? Eric Martinez give us an example, right? Yeah, the unit of velocity, for instance, the unit of velocity, right? The unit of velocity for is an example. You can have meters divided by second. You can have miles divided by hour, right? Even meters divided by hour, you can have too. But the main unit that you're going to use in physics is going to be this one here that uses, oops, that, what did I do here? Here you go. That uses the main SI units. SI stands for International System of Units. So that's allowed in physics. That's allowed in physics. Okay, so and you can invent all sorts of units provided the quantity that you're defining makes sense. You can have all sorts of units, compounded units like that. The most important here is going to be the unit for velocity that we're going to see soon. Okay, miles per second, miles per hour, right? Kilometers per second too. Here you go. I can do that. Kilometers per second. Kilometers per hour, and so on. There are all sorts of units for velocity. 1, 2, 3. And you can even come up also with centimeters per second. It's not going to be the main unit. Centimeters per hour, centimeters per day, right? Centimeters per year, and so on. But again, the important unit that you have to know, the important compounded unit, are the ones that use the International System of Units. In our labs, we will always use units. The SI units, International System of Units. SI stands for International System. International System. And by the way, this abbreviation here is from the French language. Okay, if you go to the SI, let's say International System of Units. Let's write that down here. International System of Units. SI System of Units sponsor. We want to be here. SI. Here you go. Système International. No? That's the French for international system. And you can see here we go. We are looking at those three main basic quantities. We haven't looked at the other ones yet. Let's concentrate on those three. There are 4 more. I already told you that we also have this unit for temperature. Okay, and then there are others too. This one we're going to introduce to you in Physics 7. Oh yeah, angular speed. That's right. Angular speed is, let's see, angular speed. Yeah, that's right. There is, you gotta be careful, angular speed, right? Angular speed is angle divided by time. Okay, that's what angular speed is. And angle is measured in this fancy unit that we call the radian. Okay, so here you go. Another example, right? Another example of a compounded unit. Another example of a compounded unit is the angular speed. Angular speed, which is measured in radians per second. But you gotta be careful about this unit here. Okay, this is a unit of angle. This is not the, this is where the radians, written down as rad, is a unitless unit. We're gonna talk about that, okay? It's an interesting, when we talk about the unitless unit, we mean that the unit of is, strictly speaking, is gonna be the number one, okay? And I'm gonna talk more about that. And we're going to cover that several times in the lab. Unitless unit, strictly speaking, speaking, okay? These unitless units have some, strictly speaking, unitless units have a unit of one, okay? However, for the case of angular measurements, okay, we give a name for them to distinguish different ways of measuring an angle. I'm going to elaborate that a little bit more later on. You don't have to worry about that yet, okay? Later on in the course, I'm going to elaborate a little bit more on that. And that and when you combine one unit with another one, here you go. When you combine one unit with another one, okay, we do what we call dimensional analysis. Okay, dimensional analysis is a very useful technique that we use to find out whether we are doing calculations properly. Okay? Let me give an example. I'm going to give you an example. Example. Suppose you are calculating the velocity of a given object, right? And after extensive, I suppose you're even better. Suppose you're doing a very complicated, you're solving a very complicated problem. I'm always faced with something like that, okay? Very complicated problem that involves the calculation, and then I'm gonna of the linear, and I'm doing that to distinguish that from angular, right? Versus angular, right? Calculation of the linear problem of an object. After extensive calculations, right? After extensive calculation, you find out that your result ends up being meter square. What does it mean? Which, by the way, is not the unit of velocity, right? Which, by the way, is not the unit of velocity, right? But the unit of area. Okay? What does it mean after extensive calculation, right? There you go. What does it mean, right? What does it mean to you? Right? So let's recap here, right? Suppose you're solving a very complicated problem that involves the calculation of the linear velocity, of the linear velocity of an object. After extensive calculation, and we are faced with something like that in our professional life, some time ago, I was solving a problem that took me 3 days to solve, an equation that took me 3 days to solve, okay? So suppose you are doing the same thing for this type of problem. After extensive calculation, you look, here you go, you look at your final formula, and find out that your result has a unit of meter square instead of meters per second or any other unit of velocity. Okay, what does it mean? Well, it means something very simple. Okay, so what do you think that it means? I want you to think a little bit about that before I give you the final answer, right? The act of looking at the units of your final result is called dimensional analysis, right? The procedure of dimensional analysis. But what does it mean you're getting meters square for something that's supposed to be meters per second, right? What does it mean to you? Well, I'm going to answer right now. It means that you did something wrong during your calculations, okay? That's what you mean. That's what it means. It means that you missed some steps. You made some steps in your complicated problem, resulted in the wrong answer. That's what it means. And that's how dimensional analysis is important in physics. That's one of the important applications of the dimensional analysis. That is one of the important applications in physics of dimensional analysis. Okay? To find out whether you derived your problem properly. Okay, problem properly. That's why we cover that. So get used to dimensional analysis, okay? And now what I want to do, let's see. We're doing dimensional analysis right now. How many students do we have? We still have 12 students here. There is one important unit in physics. Okay. There is one important unit in physics that is not just, let me give some, before we go into that, examples of compounded units, right? Compounded units. Okay, unit of area. Units of area can be the meter square, already mentioned to you, right? We already said about speed or velocity. Speed/velocity. They have the same unit, although they are different concepts. Okay, volume, right? What's the unit for volume? Let me know there in the chat box. What's the unit for volume? That's anybody knows what the unit for volume is? It's another compounded unit. Notice that here we are multiplying 2 units. Here we are dividing 2 units. Right? What would be the unit for volume? Type that in the chat box, please. I'll give like 1 minute to look into that. That's something we learn in math, right? You don't have to know physics to know the unit of a volume. Yeah, that's one example. Okay, Alexis, okay. Give me an example, okay, but what would be the unit of volume in the SI system of units? Right? What would be the unit of volume in the SI system of units? In the international system of units, right? $40. Okay. Examples of compounded units in the SI system. In the SI system, right? So Alexei told me that centimeters, cubic centimeters, right? It involves the cube, yes. But that's not the unit in the international system of units. This is the unit, is an important unit. The unit of volume in the international system of units should be just the cubic meter. Okay? Cubic meter. So let's, let's stick to those three, right? And now let's do something else too, right? How SI, what is the conversion, right? Let's see. What is the conversion between SI units and non-SI units, right? I'm going to give an example. And vice versa. What's the conversion between an SI unit, and a non-SI unit, and vice versa? What's the conversion? How do you, let's put in a different question here. How do you convert an SI unit into a non-SI unit, and vice versa? That's the best question. And vice versa. That's an example here. Okay. Gonna be our little example. Think about that. I'm gonna give a specific example. This is just a genetic, right? Genetic way of posing the problem. For instance, how do you express 1 cubic meter in terms of cubic centimeter? Okay, how do you convert, right? How do you express, how do you convert / convert 1 cubic meter in terms of 1 cubic centimeter? Even better, I'm gonna do something simpler than that. I'm gonna do a square here. I'm gonna do a square because cubic is a problem a little bit more difficult, okay? Think about that, how you're going to do that. And I'll give you another minute to think about it. This is something that you should have learned, right, in math, right? But I want to remind you, right, that what you see right in here, centimeter, right? What centimeter means shouldn't be capital C, should be lowercase c. And they call that the centi, right? The prefix centimeter. That's what cm stands for. The prefix centi means 10 to minus 2, right? 10 to minus 2 times the meter. You gotta remember that, right? And I'm even going to give you a little table. Let's see if I can have it here. Yeah, here you go. That's what we call centi, just one type of prefix, right? And again, those prefix work just like here are different types of prefix, right? Kilo stands for 1,000, 10 to the cube, right? Centi stands to 1 divided by 100. Milli, 1 divided by 1,000. Okay, so 1 centimeter stands for 10 to minus 2 meters. 1 millimeter stands for 10 to minus 3 meters, and so on, right? So I want you to tell me, how do you convert 1 meter square in terms of centimeter square? Think about that on your side. Area of a sector formula. Eric made this comment, right? What do you mean about the area of a sector formula? Few minutes. So here are some examples, right? How you convert 1 unit to another, right? If you convert from the other, this thing that you see here is a simpler problem than the other one that you're seeing there. Now, but 1 meter can also be written, right, in terms of what? 100 centimeters, right? All you have to do is to solve this equation that you see right here. And I'm going to write that down like that. Okay, 1 centimeter, right? Abbreviating it. Here you go. 1 millimeter equal to that, right? So similarly, 1 meter is equal to 1,000 millimeters. And we put the comma right here. And similarly, 1 meter is equal to 10 to minus 3 kilometers, right? But how do we do that for that compounded unit that you see there? Like I said, this problem is a little bit more difficult than what you see right here. And many people doesn't get it right because it, like I said, it's not straightforward. Think about that. You go. I'm gonna write it down right here. How do you convert? I'm just repeating the statement of this problem. How do you express convert 1 meter square in terms of centimeters square, right? Example. I'm gonna do that for you. Solution. Oftentimes in physics, you're going to have this type of problem. You have to confront this type of problem. And this time I'm gonna use my equation here. Uh-oh. Yep. Okay, good. Got it. Okay, I want to write down 1 meter square in terms of centimeter square. Okay, I do know that a meter, 1 meter is equal to what? 1 meter is equal to 100 centimeters, right? Just like you saw here. And that's exactly how you solve this type of problem. Notice that I put the 100 centimeter in parentheses because that's exactly what goes here. I'm going to do an additional step here. So okay, what you see right here on the left side can be expressed like that. And I'm doing that so I can go for the next step. So you can understand that 1 meter, right, has to be written in centimeters, but it has to be inside this parentheses, right? So then what we get? We get that 1 meter square is equal to 1, 2, 3, 10,000 centimeters square. Do you get that? Watch out for this type of compounded units when you're doing the conversion from one unit to another. 10,000 can be rewritten as 10 to the 4. Like that. 10 to the 4. And then, hopefully, if you understand that, you'll be able to do the next problem here. What about 1 cubic meter in centimeter cubic? Right? That's another problem. Try to do that on your own, just like before. I'll give you like 1 minute. The recipe is already here, okay? All you have to do is to make some minor changes to my recipe. Let's see how time is going. 45 seconds. Two, one. Okay, so here you go. That's how I'm gonna do it. You know, instead of square meter here, we have to replace it by a cubic meter, right? And here we also have cubic meter. Then replace my meter by centimeter, right? And then we have to cube this 100. I'm going to do, another step that I didn't do in the other one. I'm going to distribute, right? I'm going to distribute the cube inside the parentheses. Okay, here you go. And now, what do I have to do here? I have to add 2 more zeros, right? 2 more zeros, and I adjusted the comma there in the numbers. And what does that mean? 10 to the 6th power. Another way of doing that, let me show you another way of doing that. You might prefer this other way, right? You can, instead of writing 100 centimeters, you write 10 to the square, which is 100. And when you cube 10 to the square, right? We have like that. 10 square to the cube, right? I'm using the distributive property here. And then when you apply the distributive property, you get, I didn't correct that, right? That's cubic centimeter. You get 10 to the cube of 10 to the square is going to be 10 to the 6. Just another different way of solving the same problem. Okay? That's 1,000,000 here. And we can do the reverse example, right? Now we're going to do the reverse. How to convert 1 cubic centimeter in cubic meters. In cubic meters. Okay? So here you go. We start with cubic centimeter, right? we isolate the centimeter in parentheses there. What you see right in here is exactly the same as this one right in here. And instead, we go, and now what I'm going to do here, we want to change cubic centimeter, we want to change the centimeter into meter. And then what do we have to do? We know that 1 centimeter is 10 to minus 2 meters, right? And then when you, I'm gonna, let's see, yeah, I'm gonna use this one here. I'm gonna do this process here. Here you go. 10, oops. 10 to minus 2 raised to the cube, and meter raised to the cube. Like that. And then 10 to minus, when you do this operation here, this other operation, 10 to minus 6. Okay. So 1 cubic centimeter is equal to that. And instead of doing all those steps that I showed to you here, there's another way of solving the same problem. There's another way of solving the same problem. I'm going to use this result here to rewrite the cubic centimeter in terms of my cubic meter. Another simpler way of solving this problem, right, is by using our previous result. The previous result we got. By using the previous result we got. And the previous result is this one here. I want to know how we write cubic centimeter in terms of cubic meter. What do I have to do? I just do my regular algebra. Okay, I pass the 10 to the 6 downstairs, right? And then what do we get? We get 10 to minus 6 cubic meter, like that. Like that. So that's how you do conversion from one unit to another one. We start with the simple unit, right? With the definition of the simple unit, like those ones that you see here. And then you apply those definitions in terms of the compounded unit that we have. Let me write it down here, 1 kilometer. Okay. So now, we're gonna have a break very soon, right? I want to, let's see, there is one student there. Annabelle, are you there? I wanna give you opportunity for Annabelle to answer my call. Looks like Annabelle is too far away from her computer. Okay, so start thinking in terms of other units, right? For instance, how to convert square meter into square feet, right? And vice versa. Right? How to convert. First, you have to know what 1 feet is equal to, what 1 meter is equal to in terms of feet, right? You can look at the internet. How to convert square meter in terms of inches square, and vice versa. Try to do that on your own, right? And if you have any questions, problems for you to solve on your own, okay? How to convert meter square into feet square. How to convert meter square into inch square. Okay, let's see, how to convert 1 kilometer per hour into meters per second into meters per second, and vice versa, right? And vice versa, etc. Those are all types of problems that you may have for this type of this case of that we discussed here. So it's 9:53 right now. Any questions? I'm going to pause. Okay, so we are back here. So now I mentioned to you, know what I'm going to do now? I'm going to show you how to plot graphs with Excel. We will be using Excel for our labs. We'll be using Excel to plot graphs and operate on measurements, not just numbers, but measurements, okay? So the question that I have for you is, do you have any experience with Excel? Okay, that's the question I have for you. Have you ever used Excel before? Okay, I'm gonna ask you one by one, just like I did right before. Let's go one by one here. Very much, okay. Some of you said a little bit, very much, right? Let's see, a little bit, that's good. Let me call one by one, right? So before Camille is here. And at the same time, I'll give you opportunity to. Camille is not here. And Tessa, you said you have a little bit?
Yeah,
Okay.
just a little experience.
Okay, do you plot graphs with that or just use the spreadsheets? What did you do?
I used it just to like put like data in or like I take names.
Just by doing, just by keeping tables there, right? Using the spreadsheets, but you never plot anything. You never did graph anything?
No.
No, okay. Okay, I'm gonna show you how to do graphs, how to, sort data, how to write formulas in Excel. Excel allows you to do that. You can use Excel as a kind of a calculator. Okay, that's what Excel allows you to do to do, and not just a calculator, but Excel can even be used for programming as well. Excel has different levels. The spreadsheet that you see right here. I'm not sharing my screen, right? Okay, so here you go. Let me share my screen here. The spreadsheet that you see right in here, is right now what I'm doing here is just simple, filling up data, right? That's what I'm doing here. But then you can operate on that data. See that? I use the formula sum. I'm summing all those numbers that I see here. Okay, now I have better. And I can do other things with Excel too. It's amazing what we can do with Excel. You can program Excel, but we're not going to get into programming. Programming is too much. Okay. Now look here at this formula. If you already know how to program, look here at this formula here. We started on August 28th, which was Monday, right? If I want to generate the other days of our classes, what I did here, I just wrote down a little formula to generate the other dates, right? If the weekday on C1, right, is a Monday, Monday is represented by 2 in Excel, then today's date is going to be, 28 plus 2, which is going to be 30, right? And I'm generating, if it's not a Monday, if it is something else, then I have to sum the previous date with 5, because we have 5 different days from Wednesday to Monday. That's how I did it, okay? This other one here, let's see, 4th of September, right? We don't have a class. You go, yeah, 4th of September, because of Labor Day. So what I'm gonna do here, I'm just gonna write down holiday. I use Excel for all sorts of things. You don't believe it, how powerful this thing is. Okay, in my time, we didn't have Excel. So when I was doing my PhD thesis, I had to write my code in Fortran, the computer code in Fortran when I was doing my PhD thesis. And eventually I found out that some students start to use Excel to do exactly what I did in Fortran. Okay, let's see here. Let's see, this Excel is easy on a MacBook. Yeah, I think it's almost the same thing. Catherine is asking if I think Excel is easy on a MacBook. Yes, it is. I have used Excel in a MacBook, and it's almost the same thing. Okay, there might be only some minor differences between Excel in the Mac and Excel in the Windows computer. Okay, how do I access Excel? I understand that the college has a license for the students. I have never used that license for the college, but you can inquire, okay? You can get a license, Excel license from the college, not just Excel, but other Microsoft Word as well. And many computers already comes with this software installed. Okay, Eric? So that's, you can ask around. I do not know how to get the license from the college, but I'm quite sure that they do offer to our students, okay? Martinez, are you a computer or phone? Yeah, you gotta watch for that, right? I myself, Ridwan said that Martinez might be asking Martinez if he's on a computer or phone, right? Yeah, I have seen lots of students that are using the phone whenever I'm lecturing, right? I don't recommend it, okay? But if you feel well, if it works for you, go ahead, continue working, right? But because think about that, using that very small screen in your phone to follow everything that I type, right? That I type in the window, right? I wouldn't do that, but if you folks feel that you are comfortable enough with the phone, with the class, not just with the class, but also with the Excel software that you're going to use throughout the semester, go ahead, okay? Every Excel function, wow. Man, let's see. Let's take a look at the Excel functions that read one, right? Yeah, there's a bunch, okay? Oh, look at the A through Z, right? It's just like Fortran, right? Those old language, Fortran, COBOL, BASIC, they all had those functions. C, right? C has those functions as well. And, we can choose any of those. Let's see, A. Let's see what we have in A here. Accounting, financial returns, the accrued interest for a security that pays periodic interest, okay? Most of those functions we are not going to use throughout the semester, okay? But we are going to use cosine, arc cosine, sine, arc sine, here you go, return the hyperbolic cosine. I don't think we're going to use hyperbolic cosine. We may use arctangent, yeah, and so on, right? Hyperbolic arctangent, I don't think we're going to use that. There are so many functions in Excel, okay? There's even the AND function, it's a logic function, okay? So this thing works just like any programming language that are out there, okay? And it's not just work just like any programming language, but also it's far more user-friendly. So take a look at this. Really nice, Ridwan. Thank you very much for giving us this link. Oh, Bessel function, we are not gonna use Bessel functions. That's something more advanced. That's another type of Bessel function. I use Bessel functions in my PhD, during my PhD degree. Okay, I had to use those Bessel functions, and this is a statistical function. Okay, this is a statistical function. This too is a statistical function. Okay, yeah, we're not going to use a statistical function, but at least you know that they have it. Okay, look, try to count how many functions we have in Excel. We will be going crazy, right? Let's see, let's have an estimate, right? 1, 2, 3, 4, 5, 6, 7 per page, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. My goodness, 11, 12, 13, 14. Only until here, we already have 140 functions, right? I'm going to estimate how many functions we have here. Do you have the number of functions there, Ridwan? Do you know if they say the exact number of functions that they have? I'm going to estimate, maybe it's 4 times more. It looks like they have like 500 functions. Looks like Excel has around 500 functions from what I see here. Under $6, cool, yeah. Yeah, those things are usually, that is used so much, So, but like I said, Excel is a very powerful tool. Okay, make sure you learn that, and it's gonna help you for the rest of your lives. Okay, and like I said, I use Excel for all sorts of things. I use Excel to track my investments. Okay, I wrote a program to follow how much money I have in my investment. I use Excel for my research. I use Excel for my work here with the college to plot functions. And I even use Excel to animate some physics problems, okay? In Physics 39, I came up with really some cool animations using Excel. I really like it. And those animations are very useful in physics because it helps you visualize difficult concepts. Unfortunately, we didn't have that at my time back in 1980s. Okay, so that if we had it, something like that would have made my life much easier to learn. We would make my learning much easier. So let's see, one by one, right? Shiwi, are you there? Shinwi. Shinwi there? Let's see, I want to know if you use Excel before. Let's see. I don't see Shinwi here. Okay, I'm gonna put a star now here for Shinwi. Oh, she didn't come. Okay, Shinwi didn't come. Let me put it right there so I don't get confused. Destiny, have you ever used Excel? Even if just a little bit.
Yeah, I have used Excel before.
Okay, did you plot graphs or just keep track of data? What did you do?
So I coded on Excel before.
Wow. Oh, I see. That's good. So you use the macros, or what exactly did you do? Visual Basic.
We would use like codes and to like do like charts and stuff. So we would have to be in charge of like making sure like the code was right in order for like our equation and all of our like the formulas to like work out. Yeah, that was such a long time ago.
But let me see if I understand. The coding that you did was just inside the cell, or you went inside Visual Basic and work with the macros? Did you come to this point?
I think it was also basic physical basics as well.
Oh.
I can't quite remember everything from that class 'cause it was just a lot, but yeah, I used it before multiple times.
Wow. Oh yeah, it looks like you're, very advanced. Okay. It's yeah. I know how to do Visual Basic. Sometimes I work with macros. like I said, if you want to do actual coding, right, you gotta use Visual Basics. That's here, right? But you still can do lots of things in the cell. Okay, cool. Thank you very much. Thank you for sharing that with us. Destiny, are you there, Destiny?
I just went.
I didn't understand. What did you say?
Oh, you asked me if I use
Oh,
Excel.
oh, it was Destiny, right? I was not talking to Shimi. Oh, yeah. Okay, good. Thank you. Thank you for letting me know. I'm gonna put it here, a no here, so I don't get confused. Gael?
I'm here.
Okay, did you use Excel anytime?
No, I've never used it.
Never? Okay. Okay, okay. Eleodoro, is that here? I don't think so. Let's see. Elisa Gonzalez. Elisa is not here. Ridwan looks like you have used Excel before, right? Ridwan? Yeah, but which level did you manage to work with Visual Basics as well and the macros that they have in there? Just like Destiny, right? Destiny managed to do that. Did you manage to get to this point too, Ridwan? So let's see. I don't hear from Ridwan. Okay, so I'm gonna put yes. I haven't used macros or tables as much. I'd like to admit. Okay, but plenty of formulas. Good. That's good. Accounting management. Okay, good. Yeah. So basically, you're programming the cell. That's what you did, right? Just like I did it here. Yeah. Okay, good. So let's say, advanced, let's see, medium, right? Medium, let's put this way. Ashley is not here, right? Thank you very much for sharing that with us, Ridwan. James, this is James here. No. Emily is here. No. Norberto Lopez. Hi, Norberto, are you there? No,
Yeah.
nobody's. Oh,
Yeah,
yeah.
yeah.
Okay, good. Have you used Excel before?
I've only used it a little bit for project management and phasing, but formulas, no.
Uh-huh. And what about plotting graphs, right? Sometimes chart bars, right? Bar charts.
Yeah, I think we've used bar charts.
Okay, good. Thank you. And let's see, Annabelle is here now, right? Annabelle?
I'm here. Sorry, I don't have the best.
Okay. Have you used Excel before?
Yes.
Yes. Okay. Have you taken physics before?
No.
No. Okay. So I'm gonna put it. Let's put it no, right? Instead of 1 and 2. Let's put no here. Okay, good. And next one is Vanessa. Have you used the Excel before, Vanessa?
Yeah, I've used it to put in information in tables and then make graphs.
You're making graphs too. Okay, good. So, and thank you very much for sharing that with us. And Asmon is here. No. I'm gonna put it, I'll put O here. And Catherine, have you used Excel before?
Yes, I have actually in my bio and chem labs.
Okay, good. And for the labs, I believe, right? Yeah, the labs. That's good. And what did you do? Did you plot graphs or what exactly did you do?
Equations and graphs, because they ask you like to demonstrate how exactly you got to the point of the graph.
Okay, good. Okay, Camden, thank you very much for sharing that with us, Catherine. Let's go to Camden now. I can't hear you, Camden. Maybe your mic is not working. You want to type there in the window, in the chat box. No, I cannot hear you, Camden. You will need to type it for something, maybe something wrong there in your mic. Okay, just a little bit. Okay, good. Thank you for sharing that. Okay, Victoria Preciado.
I have used it a little bit a few
Okay.
years ago when I was in high school.
Okay.
Just did like the data.
Okay. Did you plot any graphs or just tabulate the data?
No, just entering data.
Okay, that's good. Okay, so you find out how we are going to plot graphs now. Alexis, did you use Excel before?
Yeah, I think I've plotted graphs and entered data in
Uh-huh.
my chemistry class, I think.
Okay, good. So let's say medium, right? Let's put it this way. And thank you very much. So, and next one here is going to be Marco. Marco is not here, right? And Eric Martinez.
I've kind of used it before just to track data on parts and work performed on city buses.
Ah, okay,
To
for
relate,
professional use, huh?
just to relate to like supervisors and
Mhm.
for Long Beach Transit where I used to work.
Wow, that's nice. Did you plot any graphs or just the tables? You work just with the tables?
Just tables.
Just tables, right? All right. That's nice, some real life data, right? So
Yeah.
you got an idea how the system is used there in Long Beach, I presume, right? from that data.
Yeah.
Oh, nice, nice. Okay, so let's start with plotting data, right? Plotting the graphs. So you can. I'm going to start with a spreadsheet. I at this point I recommend that you have a Excel spreadsheet open there in your computer and follow with me step by step. Okay, so you can get so you can start, getting some experience. We're going to plot to do the graphs almost every lab. Maybe there will be just one lab that we won't need to plot it. Okay, but the way I like to do in my labs, okay, we're gonna build up a table, okay, and I'm going to plot x, y in the y column, right, and x in the x column. And here you go. So I'm going to label here. Let's say there's a quantity that we want to plot. Let's say x is the instant of time, y is the position of a particle. Let's say something like that. I always ask you to put the units, and the units always show up in a different cell. Okay, if you're measuring in meters, if it's a unit of position, is going to be the meter, always going to be the meter. We're not going to use kilometers. We're not going to use centimeters. You're not going to use feet. Okay. Remember, in the lab, in my labs, you will always be using the international system of units. Now, just for the sake of example, right? We're going to work with some numbers that I'm going to generate for you. I'm going to put like 1, 2, 3, 4, 5, 6. Okay. In my labs, you're going to work with at least 6 pairs of data points. At least. I like to work with at least 6. Every time that I perform an experiment, I want at least 6 data points in my experiment. Not just in the labs, but also in the real life, in my research. Okay. And then I'm going to come up with some other numbers. Suppose that you got this type of numbers in an experiment, right? 2, 4, 6, 8, 10, 12. Remember, I'm just teaching you how to plot graphs with Excel. That's all I'm doing. I'm not concerned how I got this data here. Just looking at this data here. What do you think is going to be the graph that I'm going to obtain? If I plot this graph, what is it going to be? Is it going to be a parabola? Is it going to be a sine function? Is it going to be, what do you think is it going to be? Just by looking at this data. I want to hear from you. What? At coordinate 1, you have ordinate 2, right? At coordinate 2, you have ordinate 4. Okay, I heard from you. Good, Catherine. Catherine sent me a direct message, right? So the other students couldn't see it. Good, thank you very much, Catherine. You got it right. Look at this, at this set of data and let me know what type of geometrical figure, right? Or what type of geometrical figure I'm gonna get in my graph, right? If you do not know, you can go ahead and start plotting those things. But just like Catherine said, I'm gonna tell you everybody, this thing is a linear relation, okay? Yeah, that's right, Ridwan. That's exactly what it is. This is a linear relation. It's going to be twice x, right? If I'm going to, no, and now I'm gonna write down the formula that Ridwan wrote in there for me. Okay, it's gonna be equal 2 times x, right? See that? That's how I write down my formulas. You can see that this number is exactly the same as this one, right? Exactly the same. This is an equation. And now I'm going to go for the next step. I'm going to plot this data in Excel. Very important, in Excel. What do you mean, Camden? Are you asking the formula? Oh, the formula. Oh, take a look here. See that? I'm going to type it again. Every time that you type a formula in Excel, every time you have to type equal first. Every time. Okay? The relation between y and x, it's very simple. You can see from just by looking at each number separately, right? That y is twice x, right? So you write that down, 2 times x. I'm gonna click in this cell here of Excel. Do you see that it display A3? Why A3? A3 is the position of the cell. Here's A1, here's A2, A3, A4, A5, right? And then you come up with, enter, click the initial cell, look at the little square that's right here. Type the cell coordinate. Type the cell coordinate. Let's see here. Let me click and drag, right? What do you mean, Ribbon? Oh yeah, that's right. Yeah, sometimes I prefer to click, but it's up to you, right? Yeah, you can either click the cell, right? Just like Ridwan said, or here you go. Or you can type 2 times A3, right? Just like what Ridwan said. That's another option too. Okay, and if you click and drag, whatever you have here, Excel is going to reproduce as being the next cell. See, here is A3, here's A4, A5, A6, A7. Excel has this nice feature. Instead of keep on typing every formula here, just use this nice feature of Excel, clicking and dragging to generate your formula automatically in the cells. Excel has this nice feature that helps you to do that. Okay. And now we're going to plot this graph. By the way, one very important thing about Excel. By default, when you have this column here to the left of this other column here, what does it mean? It means that those numbers here on the column to the left will end up in the x-axis, okay? Maybe I should even document that, right? Plotting Excel. Let's go back to my notes. Here you go. Okay. 1. Generate a table in Excel by typing, right? By typing the pair of data points you want to plot, right? So first here, how to plot a graph in Excel, right? A graph in Excel. Generate a table in Excel by typing in the Excel, okay, in the spreadsheet of Excel, right? In the spreadsheet of Excel, by typing the pair of data points you want to plot. By plotting the pair, a pair of numbers. Let's put it this way: a pair of numbers you want to plot. Right? The data in Excel, right? By default, in Excel, and by default, the data points that are to the left of the other column will end up in the along the x-axis. Okay, by default. I do not know how to change this default. Maybe there is a way to change it. Just keep that in mind. Highlight all the numbers in your table to plot the graph, a graph, right? Highlight all the numbers in your table, right? We did that. Going back there. Make sure you follow that, right? Here you go, highlight it. This guy, I already know that's going to end up in the x-axis. This guy, I know is going to end up in the y-axis because it's to the right of the other one, right? So highlight it. Insert, right? You're going to look for the charts. Okay? There are all sorts of charts here. The chart that I like to work, that we are going to be working most of the time, is this one right in here. Charts, scatter plot. Okay? I don't like to, whenever you plot your graphs, don't use those ones here. Use just those ones without any lines connecting them, okay? So here you go. For some of you, this is the first graph you're plotting, right? Okay, so here you go. Here are the x values, right? 1 through 6, right? Here is 1, 2, 3, 4, 5, 6. And here are the y values, 2, 4, 6, 8, 10, 12, right? So that's the first graph. What else do we have to do, right? So let me document here, lecture to plot the graph, highlight all the numbers in your table, right? Next, point your mouse at the top, okay, at the top of the sheet, right? At the top of the sheet, of the spreadsheet, look for insert. That's what we did. In insert, look for graphs, specifically. What's the name of that? Insert right here. The scatter plot. Okay. The scatter plot. Scatter plot. Scatter plot. That's the type of plot. That's the type of plot. The type of plot we will use during this semester. Okay. Choose the scatter plot that has no lines but just the data points. Okay. And it's spelled out in my syllabus too. I believe I spelled out in my syllabus. Okay, and now we have our graph. We're not done yet. We're not done yet. There's more things to do. See that we have a chart title. I don't like to use chart title. Okay, so I usually delete them. I don't like this. But it's up to you. However, what you must do in every lab, okay, you must put the title to the axis. Okay. Notice what happens. Take a look at here at the top of the spreadsheet, right? When I click the graph, two other options appear. When I unclick the graph, the two options disappear. Right? So if I want to work in this graph, if I want to put some axis, name the axis and so on, I need to click on the graph. And then you go to chart design. Okay? There's also the option of formatting, okay? I'm gonna be working with chart design. In chart design, we can add chart elements. And what do we have here in this chart element? We have the axis, primary horizontal, axis title. That's what we have. But they will have other options too. Okay? But the one that we're going to use it is the axis title for now. If we want to put an axis title, we have to use this option. There are other options too. But let's start with the axis title. Okay, when I click primary horizontal, it creates a little square here for you to type the axis, the title of the axis. Okay. And then we want to put an axis title in the vertical as well. Here, you name it as X and you put between parentheses the unit. I'll be asking you to do all of that. Here I'll put Y and I'll put between parentheses the unit as well. For those axis title, I like to boldface them so they stand out in your graph. You just click the text there, right? And I usually put in a larger font format. There's a way to do that. If you right click, font, choose font here, maybe 14 size. Yeah. I usually like to do that. Here you go, font, click, click and right click, 14. Here you go. I also like to boldface the numbers. So again, they stand out. I usually make the title of the graph larger than the numbers in the axis, along the axis. Okay, so let's document that. Okay, so lecture notes 2. No, not this one. Lecture notes 2. Is it 3? Yeah, interesting. Okay, let's get this guy here. Yeah, okay. Okay, so after choose the scatter plot, at this point, you have your plotted graph, right? The graph will be plotted without the axis title. Okay. Click on the graph and choose what? What was the option that we choose there? Graph chart design. And choose chart design. Okay. To the extreme left of chart design, you have the option add chart element. The option add chart element. Click on this option. Click on this option. A drop-down window will show up with another option, with the option, with several options, right? With several options. So highlight access title, right? Highlight access title. Access title. Add horizontal, right? Horizontal. Primary horizontal and highlight primary horizontal. Highlight primary horizontal. And afterwards, primary vertical. Okay. A rectangle will show up next to the axis of the graph. Okay. Type the axis title with its corresponding units. That's what we did. Axis title, corresponding unit. That's what we did. Those are the step-by-step instructions here that we have. But there is more that we have to do. There is more. Okay, so far we have done a lot, right? Everybody's following? Do you need a little of a break here? Am I doing too fast?
I had a quick question.
Yeah.
How did you enlarge the numbers again? How did you make them bold?
Oh, okay. Yeah, here you go. You highlight, you click on the numbers, right? Click on the numbers, right click the numbers. In Excel, in my Windows is set up like that, okay? And then you look at fonts. You know, you have the option of, you know, boldface, increase the size, see that?
Yeah, I got it now. Thank you.
But, oh yeah, that's right. And then there is this other option that Ridwan mentioned, right? You can click the axis and then you Control B for bold. That's a shortcut.
Yeah.
Yeah, at least for Windows, right? Maybe Mac is gonna be different. Maybe the Mac is gonna be different.
Okay, yeah. Thank you.
Okay, everybody has a graph there right now? Yeah, B for bold, right? Yeah, Mac is command, right? It's not control, yeah. Mac used to be a better computer than Windows, okay? Now I think Windows caught up and it's almost the same now. My first computer that I bought was back in 1996 and it was a Macintosh, an old Macintosh. And then later when I switched to Windows, I still have a Mac here because I had to do some things. MacBook, I still have to do some things in the Mac that cannot be done in Windows. But I use Windows most of the time now. Yeah, well, I don't know. Well, if you're used to Windows, right, it's difficult to pick up on Mac, right? It was since I started using when I used to work at NASA, the computer that we used there in my branch was only Macs. That's what we are using, right? And I kept using Mac for several years. And then when I had switched to Windows, it was so difficult to get used. You know, I'm just on Windows, and when I get my Mac, yeah, it's difficult. It's difficult to switch back to the Mac. Yeah, I got so used to that. That was Catherine comment, right, Catherine? But some people they just love the Mac. They don't want to leave it. Oh, they have everything Mac, right? They have the Apple, everything Apple, right? The Mac computer, the Apple Watch, the cell phone from Apple. You know, some people are just like that. Apple built a brand name around that. The very valuable brand name, Apple, right now. Okay, so now what we have to do now? Everybody got to this point? I want to know if you all got to this point. Okay, let's see. I'm gonna ask you if you plot the graph, all right? Let's see how I'm gonna do it. I'm gonna do like that. This guy, I'm gonna move here. Plot graph. What happens? Camille is not here, right? Nope. I want to know, let's see, Camille is not here. I'm gonna put 0. Tessa, did you manage to plot the graph?
Yeah, I figured it out.
Okay, good. Shinwi is here. No. Destiny, did you manage to plot the graph?
Yes.
Okay, good. Gael, did you manage to plot the graph? Yes, good. Okay, Eleodoro is not here, right? Next in line is Elisa. I don't see Elisa. Ridwan, you plot the graph, right, Ridwan? Yeah, good. Thank you. And Ashley is not here. No. James is not here. No. Emily is here. I don't see Emily. Next, Norberto.
Yeah.
Yeah, you plot the graph. No problem, right? Annabelle?
No, I didn't. My laptop's like going really slow.
Oh, I'm sorry. Okay, see if you can get a desktop, right? Try and also try to do that in your spare time whenever it gets better. I'm gonna post to this class, right? This class I'm recording right now. Vanessa, did you plot the graph, Vanessa?
Yeah, I have the graph, but I was confused on how to add the y-axis title on there and then the x-axis title.
Okay, let's do that again. Let's see, let's do that again. And this one here. I'm gonna erase my title, right? Right, here you go. Right. Do you have a Mac or a Windows?
I have a Mac.
Mac. Okay, Mac must be a little bit different, right? But
Yeah.
in the Windows, it's like that. You click the graph, you click on the graph. Okay, and this chart design option shows up. Do you see that in your Mac? Chart design and
Yeah,
format.
I see it.
Okay, now click on chart design. Okay, in the Windows, we have this add chart element that shows up on the extreme left. Do you see that, the add chart element?
Yeah.
Okay, drop down window, axis title. See that? Primary horizontal. And now he has this option here. Did you get that?
Yeah. Yes.
And now you type, right? X, parentheses, the unit. And so once you get here, you have most of it. Then it's just a matter of detail, right? You boldface, I believe I put like 14 size, right?
Mm-hmm.
Got it?
Yeah.
Okay, good. So let's see. So it is Vanessa, right?
Yes.
Okay, good. So Vanessa got it, right? Nazmo is not here, right? Nazmo is not here. Catherine, you managed to do that, to plot the graph, Catherine?
Yes, I got it.
Everything good, thank you. Camden?
Yes. Can you hear me now?
Yeah, now I can hear you.
Oh,
Yeah.
okay. So I was muted. I have a question. I
Uh-huh.
think I remember there's like an option to have this formula to use
Uh-huh.
this plotting chart. Do you know what that is? Like there's like some types of like formula to display on the chart.
Oh, are you talking about a function in Excel that plot the chart for you? Is that what you mean?
Maybe. Oh wait, I think I think wait. I think it has to do with like the trend line or something like that. I learned this from like statistic class long
Yeah,
time ago.
we're going to do that very soon. Hang in there.
Oh, okay. All
We're
right.
gonna
Thank
get
you.
into the trend line. Yeah, we're gonna get into the trend line. For now, I'm just making sure that everybody's following, right?
Oh, okay.
And that the procedure for the trend line is spelled out in the syllabus. Check
Oh,
the
okay.
syllabus there. Yeah,
All
that
right.
I'm
Thank
sure
you.
I spelled out. Okay, so you plotted. You're good at up to now, right, Camden?
Oh,
Yeah,
I'm not good, but I did it.
you plot the graph, right? You plot
Yeah,
the
I
graph.
plotted. Right. Yeah.
Okay, Victoria, did you plot the graph?
Yes, I did.
Okay. Next, Alexis.
Yeah, I got it.
Good. Marco is not here. And Eric Martinez. No problem there, right, Eric?
Yeah, I got it.
Okay, good. So now we're going to do what Camden, right, mentioned, right? We're going to go for the statistical function, okay? Okay, now how do you do? Well, Excel, there is a mathematical technique that we can use to determine the equation of this line that you see right here. Okay? This one, you already know what the equation is. The equation is 2 times x, right? But when we are performing experiments, we do not know, it doesn't become very clear what would be the equation. So we use this function that's called the trend line. The trend line to get what we call the regression equation. Okay? What you see right in here in an actual experiment is your real life, okay? And then this regression equation that you're going to get is going to be a model to your real life, a mathematical model to your real life. Because this is not an actual data, but just something I came up with. The trend line that I'm going to get here is going to be exactly what I told you, 2 times x, right? And how do we get the trend line? Okay, to get the trend line or the regression equation, you click one of the data points, make sure all the data points are highlighted. Okay, we're going to be doing that all the time in our labs. Right click and look what we have here, add trend line. Okay, add trend line. Trend line is gonna give you the equation that's closest to your data point. And there is a mathematical procedure to do that. Okay, so if I highlight add trend line, I'm going to have this pane, this window showing up here on the right side. Do you notice that we have all those options for the functions? We can fit an exponential function to this data points. We can fit a linear function to those data points, a logarithmic function, a polynomial function, a power function, a moving average. During the semester, most of the graphs that we are going to do is going to be the linear one, okay? And so much it's already checked in there. Actually, that's the default of Excel. And what else do we need to do? You have to display equation on chart. See the equation here? Excel is smart enough to calculate that for you. And we have to do something else too. I shouldn't have done. Okay, here you go. We're back. I want you to check this box as well. Display R-square value on chart. I'm going to talk more about this R-square value, okay? So display R-square value on chart, and we have the value of R-square. So that's how you get your trend line and the R-square value. The R-square value has a name. it has an important statistical function, okay? And I'm gonna explain soon about that. Let's, any questions about that? This procedure is on the syllabus, okay? What I want to do now, I want to go for a break again. Break 11:05 a.m. to 11:20, okay? And after the break, we continue with that, okay? See you in the next 15 minutes. Okay, we are back. 40 more minutes to go. Here you go. We are back to our graph. At this point, you should have a graph with the regression equation or the trend line, the same thing, right? And here is my important statistical parameter. This statistical parameter is called, there's a name for this statistical parameter. The statistical parameter is called the determination coefficient. Okay, let's write it down. Here you go. Break. Okay. Find the trend line and the determination coefficient. That's the name it in statistics, which is the R square. R square is the determination coefficient. Okay, but then there is something else. You know, R square is related, right? If you took a statistic before, R square is related to the correlation coefficient, okay, which is R. R is the correlation coefficient, R square is the determination coefficient. Correlation coefficient, R. So for some reason, Excel plot the R square instead of the R, okay? For some reason, I do not know why. They have chosen to use the R square instead of the R. But it's a straightforward relation, right? Determination coefficient, right, is equal to the square of the correlation coefficient. Okay. And determination coefficient. This determination coefficient has a very important interpretation. There's a formula for that. I'm not going to write that down. Okay, if you want, you can take a look at the internet. It's a very big formula, very complicated formula. Let's take a look here. Correlation coefficient. I'm not going to cover in detail. I just want. We should, let's see. Correlation. Let's look. Coefficient formula. Yeah, here you go. Correlation coefficient formula. That's the formula of the correlation coefficient. Okay, here is the data point xi, can be x1, x2, x3, okay? It's a summation, and here's the average of x. Here's the y, y1, y2, y3, minus the average. And everything must be summed up. x1 minus x average times y1 minus y average, plus x2 minus x average times y2 minus y average, so on. And here we have the same thing. There's a square root here inside. Okay? That's the correlation coefficient. The determination coefficient is the square of this value. This is square of this value. The regression equation, there is also this equation that you see here. There is also a very important procedure. There is a procedure that you have to use to find this equation, okay? It's possible to do that. Again, it's a little bit complicated, but you know, you can find the internet. Let's see if you can get it here. Regression equation. regression equation formula right in here. Okay, there's a way to derive that, and the way that we derive, we as here you go. Let's see. Okay, here you go. Let's see. This one. Let's take a look at this one. This is better. Okay. Here's the equation. You have a set of data points in your graph, and you want to find an equation that best fit that data. So you write if the equation seems to be linear, you write that down as a plus bx, right? Whereas a is equal to this formula and b is equal to this formula. How do we reach this formula? We reach this formula by doing the method of the least squares, the least square method. Okay, we minimize the square of the distance between the data point and your regression equation. Okay, if you took statistics, most likely you have already seen that, and maybe your professor even have derived this formula. It's possible to derive that. Well, I don't do that here because it's too much work. Okay, but that's what is programmed into Excel when you find that equation there, using the method of the least square. Okay. Now, I want you to understand. Okay, so what's the interpretation for this guy here? A very important mathematical interpretation for this determination coefficient. The determination coefficient is a value that goes between 0 and 1. Okay, let's write it down. The determination coefficient has values between 0 and 1. And what does it mean? Okay, the larger this coefficient, let's write it another way. This coefficient is a measure of how close the regression equation is to the data, to your data points. Okay, 0. If our R square is 0, it means that your regression equation is very far away from your data points. It's not a good fit. Okay, if R square is close to 1, it means that your regression equation is a good fit to your data points. Okay, the closer R square is to 1, the closer your regression equation is to the data points distribution. Right? An R square equal to 1 means that you have a perfect fit to your data points. Okay, perfect fit to your data points. That's why I got R square in there equal to 1. I got R square equal to 1 because when I generated this data here, all I had to do was to multiply the X by 2, right? Something like that doesn't happen in real life. Rarely happens in real life, R square equal to 1. Rarely, okay? If it happens that you are getting R square equal to 1, you either did what I did here, I made up the data, okay, on purpose, or you cheated, okay? Students, sometimes they think that they should get an R square as high as 1, right? So they start to fudge a little bit with that data point, or 3 possibilities, right? I created from scratch, so you can understand how those things work, or maybe you cheated, right? Or another possibility is that you were working with instrumentation that did not have much resolution. I have seen that happening. Okay, I was doing an experiment with my students, and I was getting R squared equal to 1. Even I was getting R squared equal to 1. When I went figuring out, investigate why that was happening, I discovered that the ruler that we were using didn't have millimeters in the scale. Let me show you the ruler here. Here you go. Here we have a ruler that didn't have those small divisions here. The instrument didn't have too much of a resolution. Okay, and because of that, we were estimating a value that ended up resulting in a R squared equal to 1. Okay, that was happening. Now, what we're going to do here, I'm going to simulate some real life data points. Okay, so you can see what happens to my R squared. Remember, right now we have a perfect fit for this equation. R squared equal to 1. But what if your data point was not exactly 2 here, but it was 1.9? Okay, look what happened to my regression equation. My regression equation, I'm going to undo it, right? Remember, my original regression equation was y equal to 2x, right? But when I change my first data point, which would be something that I would get in real life, my equation changes slightly. It's still close to 2x, but it's not exactly 2x. It's 2.0143x with a intercept that's not 0. And look at your R squared. R squared decreased from 1 to 0.9999. Okay? It's not perfect fit anymore. But that's okay. You never get a perfect fit when you perform experiments. You never. Okay, and if you do get a perfect fit, that something went wrong there. Okay, and here you go. What happens when I change my 4 to, let's say, 4.05, which would be like I said, a result type of number that you'd get in real life. It's not a perfect fit again. The equation changes slightly, right? I'm going to put 6.1 here now. Okay. See, you can see that the R squared changed from 0.9999 to 0.9997. Right? You got a worse fit than what you had before. Here you go. Before you had 0.999, and now you're getting 0.9997. Well, it's worse compared to the previous one, but it's still a good fit because it's very close to 1. Okay. What else? Let's say 8.2. Gonna be more like what happened to R squared? You know, it's becoming further and further away from y equal to 2x, right? We had 0.9997, and now we have 0.9993. But the equation is pretty close to y equal to 2x. It's not exactly y equal to 2x, but it's still pretty close. Okay, here is gonna be, I'm gonna put 9.5. It's gonna be like a let's see, there's a chat message here. Sorry to interrupt, but how did you add the formula onto the chart? Okay, let's do it again, right? Let's do that again. The formula to the chart. I'm gonna erase it. Gal, right? Let's do that again. I'm going to start from scratch. But are you getting the idea here, right? What I'm doing here, I'm just doing a simulation on what an actual data should look like, right? But let's go from start, right? Here you go. Well, I'm gonna use, let's see. Here you go. I'm gonna erase it. By the way, the step-by-step is in the syllabus. Okay, girl, we're gonna do that again. Here you go. You click the data point, right? Click the data point, right-click it, and you add the trend line. Okay, make sure that the linear trend line option is checked. Under some cases, you might want to use the other ones, okay? and you check the box display equation on chart, display R square value on chart. Okay, like that. Make sense? Now, that's how I get the equation. You have to check that box. Okay, you have to check those two boxes. Okay. So let's go back where we were, right? We go undo, 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 undo. Oh, what happened here? No, it has to redo it, not undo it. Redo, no. Okay, and then I have to redo it, all the numbers here. What did I have? 1.9, 4.05, right? I don't remember exactly what I had, but let's see. Here would be like 8.5. Here, 8.5 is which one? Is this one right here? Okay. 10.1. And I say 12.5. Okay. We still have a number for R squared that's very close to 1. Okay. So that's what the R square is all about. The R square is a measure of how close this equation, which is represented by this dotted line, how close this equation is to the data points. It's very possible that you end up having something much more different than that, okay? Let me just erase this guy here. We don't need that anymore. Okay. 1136. So did you get the idea how R square is used? And let's see if I have anything else that I have to share with you. Okay. Think a little bit about that. And we'll be doing something like that over and over again throughout the semester. Plotting the graph. Most of the graphs are going to be linear, and I'm going to come up with the regression equation and the R square. And then there is one more thing. One more thing that I like to do with my students. Okay. First time I heard about this R square, first time in my life, I never took a course in statistics, okay, which is a big mistake. But the first time I learned about R square was when I started working at NASA. Okay? My boss showed to me those spreadsheets, okay, and he showed me the R square. That was the first time I heard of. But then later on, I learned about something else too. And then one day I start reading a book in statistics, and I learned about another parameter, another very important parameter in statistics. So here we go, which people have been neglecting for a long time. I do not know why they neglect this important parameter in statistics. And I like to share that with you folks. When I was there at NASA, my boss just told me what this number is here. It's like a percentage, right? The data is 99.83%. The regression equation was 99.83% closer to the data points. Nothing further from the truth. Very further from the truth, okay? R squared, only give you a qualitative idea of how close the equation is to the data points. That's all. If you want to know a quantitative idea of how R squared is closer, how the regression equation is closer to your data point, you're going to need something else. Okay, so let's go there. This one here. As it was said before, R square is a measure of how close the regression equation is to the data points. Okay. But this closeness is just a qualitative measure. If you want, qualitative, very important. If you want to have a better quantitative, qualitative versus quantitative idea of how close the regression equation, right, is to the data points, you must also know the number of data points in the graph, the number n of data points in the graph. So n r squared will give you a better idea of how close the regression equation is to the data points. Right? R squared alone is not good enough. You also have to know the number of data points. Okay. In our example, n equal to 6, right? Going back to the spreadsheet here, you have 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6, right? Those two values combined gives you a better idea of how close, in our example, n equal to 6, and gives you a better idea of how close your data points is to your regression equation is to your data points. R squared in this case is 9983. In our example, 0.9983. Okay. Once you have these two values, you can find what we call the confidence level, or CL. Okay. Whereas CL is a function of n and r squared. Okay. CL is a better quantitative measure. Better CL, what's going on here? Quantitative measure of how close the regression equation is to the data points. Right? So, and I want you to understand the difference between the regression equation and data points, right? Data points, is real life. Regression equation is what? Is your mathematical model, okay? Don't forget that. You always try to build mathematical models of the real life. That's what physics is all about. Notice that we always try to build mathematical models of the real life. Right? That's what physics is all about. Why do we do that? That's what physics is all about. Why is that? Why is that? Because we want to have a predictive because we want to have the ability, okay? The ability to predict how nature behaves. And the regression equation is one of these predictive tools. Okay? So that's what science is all about. It's about predicting what's going to happen in the future or what's going to happen under certain conditions for a given system. And the regression equation is just one of those tools, in addition to the physics laws, to the laws of physics. Okay. So let's talk about the confidence level now. That should be, that's not as easy to grasp. It's not as easy to calculate. Excel doesn't have, doesn't calculate the confidence level for you at all. Because of that, I came up with a table. Let me get my table here that we are going to be using throughout the semester. Let's see, confidence level here, 38, no, 3007. I'll get it. Illustration download. Lab reports here. Confidence level right here. Okay, let me transfer somewhere else. This table you're not gonna find anywhere. Okay. When I first came up with this table, there were other tables like that that were much simpler than this one that I came up with. I figure out it's not easy to generate this table. You have to understand how to make those calculations that are gonna lead to the confidence level. And I finally discovered how to do that. If I want to keep the procedure, right? How to calculate that as a trade secret. All I do is I provide you only the table instead of the actual mathematical manipulation. That's all you're gonna need in this course. You don't need to know how I came up with that table, okay? And confidence level right here. I'm going to upload that to okay, let's see. I'm going to upload that here. Maybe I already have it. Do I have it? Let's see. Files, lecture and lab notes, confidence level. No, I do not have the confidence level table here. I don't need that anymore. Syllabus, remove, delete. 1, 2, I don't need that. Lecture notes, I'm gonna leave it here for now. And I am going to post the confidence level right here. Go to home. Add item. Now you have your confidence level table there. And you're going to need, you have to, take a look at this table. You have to understand how it is organized. You're going to look into that over and over again. I'm going to display this confidence level table here for you, okay? And let's see if I have an illustration of how this table looks like. If I don't have, I'll have to do that from scratch. No. Ay, 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 ay. It's so sad when you have to do everything from scratch and you know that you have done it before. You just don't know where it is. It doesn't look like I have any choice here. Otherwise, it's gonna take too long. Let's see at the bottom. 10 minutes to go, right? Yep, 10 minutes. Okay. So let's go ahead and I'm going to start here a new blank presentation. Okay, I'm going to name that save as P06 illustrations, right? Fall 2023. Let's navigate to your page. College. Harbor, the folder. Okay. Take a look at the table here, this table right in here. Let's see by lab manual. Okay, that's why it's written Appendix I, Appendix 1. I wrote it down, critical values of R squared for different confidence levels, okay? Let's see how it's organized. Okay, you have the number of data points right here in this column. Okay? I usually like to work in this region here, 6. 6 or more. Every time I perform experiment, I want to collect at least 6 data points. Okay, so here you go. You have to concentrate only in this column and this row. Everything else is unnecessary. Okay, this row is N, this column is N, this row is the confidence level. You see here, CL, confidence level. And everything else here that you see here is your R square value. I'm gonna show that to you. I'm gonna make an illustration so you can understand better. Have a picture. Here you go. This one. I've done this table. What I'm doing here, I've done it so many times, but I can't seem to find my previous tables. Okay, here's my table, right? So we have go back there. Okay. N equals to 1, 2, 3, 4, 5, right? Right? All sorts of numbers. Here you go. Here's that column that you saw. Right? This is a simplified version of what you saw in that table. Column of N. Oh, see. Oh, it starts at 3, by the way. Okay, starts at 3. Not that one. Starts at 3. You have to have at least 3 data points in your graph to generate a linear equation. Okay, you cannot have less than 3. And in the horizontal direction was the other one, right? It's right in here. CL. CL. CL is 0.95, right? And then you have 0.99. Oops, I gotta stretch it in the horizontal direction. The way I built this table, you know, CL is a measuring, can be written down in terms of percentages, okay? Here you have 95%, here you have 99%, 99.99%, and so on, right? 0. That's how I build up the table. Okay? And what else we have? We have the R square value here. Here you go, and I'm going to increase the size of this R square. So let's see, 300. Oh, too much. That's what you have to know about that table. Can you remember that? Everything else here, the body of the table is the R square values. Okay? Given n and a given R square value, you can find the CL. That's what this table is all about. Okay? So let's say we have n equal to 6, and let's say you perform an experiment and you obtained a R square value that's exactly this number here. 4 more minutes to go. Find the CL. Okay? I'm gonna give you an example, right? Here you go. Copy my image. You go. Example. Suppose you performed an experiment and collected 6 data points. Data points n equal to 6. And obtained and found, right? R square value, R square equal to how much? 0.983715. What is your confidence level? What is the CL? What is the CL of your regression equation? Okay. Running out of time, 3 more minutes to go. That's an example. Okay. Solution. Going back here you go. N equal to 6 R square, you know, you're lucky enough you got an R square equal to 9.983715. And then what you got? You have a CL that's equal to this value here. Okay. So it should be the intersection, right? The intersection of CL with 6 should be their R squared. So your confidence level should be 1 minus 10 to minus 4. 1 minus 10 to minus 4. Let's take a look here. You go. 1 minus 10 to minus 4 is what? 0.9999. 9999. 99.99%. Okay. So using the table, right? Using the table provided, the CL is 99.99%. Okay. Is 11:59 right now. So that you can apply the same one for other values, okay? Any questions about that? Go ahead, download that table for you. And In the
Hey,
next
Professor.
lab, we elaborate a little bit more on the CL. Yeah, any questions?
Yeah, well, what did you type on Excel? Like, what was the equation for it?
The equations, let's see, let's go back to Excel, right? Which equations?
Number 16.
16, okay.
Oh,
16.
okay, let me copy there.
Yeah. Okay, so what, where did I get that? I got that from here, right?
Right,
1
yeah.
minus 10 minus 4. Okay. So what did I do? Equal, right? Equal 1 minus 10 power minus 4. And then Excel calculates that for me numerically.
Oh, okay.
Okay.
All right, thank you so much.
Okay, I hope you have, if you want to know in terms of percentage, right? All you have to do is multiply by 100 and you get 99.99%. Okay. In my labs, you will need to provide those types of values, not in percentage wise, but fractional, in a fraction. Okay, so it's 12 noon right now. I didn't finish everything that I want to finish for Porfirio, but we will do that next week, okay? You don't have any questions?
Are you gonna post this recording? Are you gonna post this recording on the Canvas page?
Yes, I'm gonna put a link there for this recording. Yes.
Okay, thank you.
And just like I said, I'm not gonna edit anything. It's not gonna be any Avengers movie type of, quality, right? But maybe it's gonna be helpful for you. Okay. And if you want to see the previous years too, you can also look there the previous years. What I did in the previous years is rather similar to what I'm doing right now. Okay. One day I plan to go ahead and edit it, all those videos that I created, so I can make them more compact, right? So maybe I should do that like a extra credit, right? If you folks wanna get any extra credit, you can look at those videos of mine. You can do some editing for me, and I'll give you some extra credit. What do you think?
Yes, but what was the extra credit? Can you say it one more time?
Yeah, I was thinking about give you like extra credit. It's not gonna be lots of grades. It's gonna be like only 5%. If you can do some work with the videos, doing the videos of mine that are posted there online in my YouTube channel, eliminate all those sections that I'm not saying anything that's going too slow, doing some editing of the videos basically. If you're interested, if you have some knowledge how to do editing, video editing, that there's an opportunity here for an extra credit. Okay?
But what channel? Your channels or like
Yeah,
our
my channel,
Oh,
the
okay.
one that's in the syllabus, right? So if you go to YouTube.
So when we do the editing part, do we have to submit the videos to you via to your email or like on Canvas? Like
Yeah, we'll figure out if we figure out a way for you to submit that to me. Maybe we put that in my Google Drive account.
Oh, okay. Yeah.
And then I'll go through the video, see how good the quality is, and then right now, see the playlist that I have: Physics 7, Physics 38, Physics 39, Physics 6. We're looking at this one. This one were the recordings of last year, from September 7th, 2022 to November 16th. What's that? Oh, no. Wait a minute. It's me speaking. It's me speaking. Oh, I thought it was one of the students. Okay, so if the link is there in my syllabus, but let me send you the link again, everybody's link. Let's see, for everybody. Link for last year's Physics 6. Like I said, it's not going to be much different from what I'm doing this semester. Maybe this semester I'll add a little bit of material that I didn't have time to cover last year, but that's the link That's your physics 6, right? Okay, that's the one. Okay, so they're all here. Okay, any more questions? Think about that. If you're interested in doing any extra credit, just talk to me, and then I'll give you some guidance how to do that.
Yeah, I would like to do it, but how many videos do we have to edit?
It's 5% of the credit. I must calculate that would be like 20 hours of work. 5%. So you keep a track of how many hours you're spending, and then I'm not gonna tell you do 10 videos. I'm just gonna tell you do 20 hours of work. So each video is like 3 hours, 3 hours long. Maybe you're gonna spend let's say 6 hours per video, right? Because you're doing editing too. So we
So
can
we have to what do we need to do? Like what kind of work do you
doing some editing, because those videos I didn't edit those videos. So what I would like to do, I would like to remove the parts of the video that I'm not doing anything.
Oh, okay.
Understand? I want to remove the parts of the video that are not they're not central to the work, to the topic that we're covering. For instance, those videos have the recording of me doing the attendance, right? I don't want the attendance there in the video. Right?
Okay.
Because all I want is just the video relate to the physics course itself, right?
Okay.
So that's what needs to be done. So I suspect that would be like three or four videos for a 5% grade.
Oh, okay.
Okay.
3 or 2. Okay.
Yeah, because those videos are 3 hours long, right? Since you're going to be editing, maybe it's gonna take you 6 hours to do each video. You don't have to do everything at once. You can do in little chunks, right? Little chunks throughout the semester.
So when are you going to upload these videos?
I think you can do today's video. Oh, you're talking about
No,
today's
I mean just overall everything. Like, are you going to do this like end of the semester or like
you mean the extra credit?
Yeah, the extra credit.
Yeah, you can start right now if you want.
Oh, okay.
If you want, yeah. And remember, it's lots of work. Let me stop the recording here.